Dear students, welcome to this video on simultaneous faults. This is Unit 5 of subject Computer Methods in Power System for BTech Electrical Engineering. I am Uttam Satpute, Professor Electrical Engineering Department at Dr. D.Y. Patil Pratishthan's College of Engineering, Sadunke Nagar, Kolhapur. So let us start with the syllabus, Unit 5. It is simultaneous fault by two-port network theory. So in this Unit 5, we are going to look at what is two-port network. Already it is learned in electrical circuit analysis. Here it is a prerequisite for this Unit 5. Along with this, we are going to learn interconnection of two-port network. It is just an extension of two-port network theory. And using this concept of interconnection of two-port networks, how it can be used for fault analysis of simultaneous faults. So we have three simultaneous faults here: Z type of fault, Y type of fault, and H type of fault. Here are defined the learning outcomes of this Unit 5, LO1, that is first learning outcome, simultaneous faults. So what is simultaneous faults? Then modeling a network by two-port network theory and numerically, that is learning outcome 2, and the label goes from L1 to L3. Then we have third learning outcome, interconnection of two-port network and numerical. Here also the level goes from L1 to L3. And finally, the last learning outcome, LO4, simultaneous fault connection of sequence networks, where we are going to learn three simultaneous faults: Z type of fault, Y type of fault, and H type of fault. So before going to the syllabus, let us have a small revision which you already learned. What is fault? Already we learned that when the current takes undefined path, then fault is said to happen. For example, suppose if I have a transmission line, suppose if I have a transmission line and now I expect, I have shown all the three lines over here, A, B, C. You can say A, this is R, Y, B also, you can write R, Y, B. Now we are expecting the current to flow in the lines, in the conductor, which is connected between the towers and insulator. But if there is a, say, some tree is fallen on the transmission line, or there is some connection happening between the line and the earth and the ground, then the current start flowing from line to earth. Then we say that the fault is occurred, because here the current has taken an undefined path. Similarly, suppose if the two lines get shorted, then also then the current starts flowing between these two lines because of the potential difference. Then we say the fault is happening. Okay. So in general, what is fault? Already we learned, when the current takes undefined path. It may be due to insulation failure. Okay, in most of the devices we say the earth fault take place when we get a shock. So that is also a type of fault. Okay, just now what are the types of faults? This is general. Okay, we are not talking about simultaneous. The types of faults. So already we learn there are there is one category called as symmetrical fault. So what is symmetrical fault? Already we have learned, but I'll just revise once again. Suppose if I have a transmission line, say line R, line Y, and line B. And if all the three lines get shorted like this, and if it is connected to ground also, if it is shorted to ground. So there are, you can say there is either three-phase fault or three-phase ground fault. And now this type, now currents start flowing between these uh, faulted faulted line fault. So we say that the three-phase fault or symmetrical fault is happened. Now this fault is also called as balance fault. We already learned why it is called as balance fault, because the current that is flowing in the three lines or the voltages, phase voltages or line voltages, they remain balanced. So what is balanced? Suppose the current in line R, if it is say 100 at an angle 0, this is after the fault. Now the current in another phase, it will be magnitude 100 and the angle will be minus 120, and the current in another line will be also 100 at an angle minus 240. Then we can see this, that the magnitude of the current remains same, and there is a phase shift of 120 degree in between the currents or even maybe the voltage. Then this fault is called as balance fault. The system remains balanced. So how to deal with this analysis? This can be dealt on single phase basis. So that is already we have learned in this chapter. There is another type of fault which is called as unsymmetrical fault, and it is also called as unbalanced fault, because now when this fault take place, unsymmetrical fault, then system do not remain balanced. The current or voltage will not have same magnitude and will not have a phase shift of 120 degree. Now there are two types of unsymmetrical fault. One shunt type of fault. So here we have line to ground. Line to ground means what? Suppose R phase only, if R phase only if it is connected to ground due to some tree falling or whatever, then it is said to be LG fault. Second is line to line fault. The second one is line to line fault. Suppose if two lines get shorted, then we say that line to line fault is taken place. Or line to line, if two lines are shorted and it's connected to ground, then we say that LFG fault is taken place. So under these fault conditions, the system becomes unbalanced, and we have to use symmetrical component theory for the purpose of analysis. That is already also we have learned. Now, there is another category of fault. There is another category of fault is called as series type of fault. So, in this series type of fault, we have one conductor open. Suppose if one of the conductor, you have three lines. Suppose if the one of the line gets open, the other lines they are healthy, whereas one of the line gets open. Okay, so then it is called, it's cut. Then it is called as one conductor open. Suppose if another conductor also gets open, then it is called as two conductor open. So these are unsymmetrical faults. Okay, now let us continue this. Okay, now we come to simultaneous fault. What is simultaneous faults? Now the fault that take place simultaneously are called as simultaneous faults. Okay, so now types of simultaneous faults. We have Z type of fault. Suppose we have a transmission line between two buses. Suppose this is bus number 1 and bus number 2. Now what is meant by Z type of simultaneous fault? Z type of simultaneous faults means if at the sending end, this is sending end, this is the receiving end. Suppose if here we have a LG fault at the sending end and we have a LG fault at the receiving end, and these two faults take place at a time simultaneously, then we say that it is Z type of faults. It is also called as another name is series type of fault. So why it is called as Z type of fault? Because we can use the uh, mm, impedance, that is called as impedance, what we called Z bus. Z bus can be used. Z bus it can be used for the purpose of analysis. Okay. Uh, Now, what is the percentage of this type of fault? Actually, a percentage of fault taking place in the power system is very, very less. Most of the fault that take place, they are unsymmetrical fault. 95% faults, they are, unsymmetrical faults. And around, uh, say around some 10%, it is symmetrical faults. Okay, these simultaneous faults, it is very, very rare to happen in the power system. Then we have another type of simultaneous fault which is called as Y type of fault. So what is Y type of fault? It is also called as parallel fault. Now in this LLG at two locations. Suppose at receiving end we have LLG fault, that is line to ground fault if take place at the receiving end. Also there is line to line ground fault taken place at the receiving it simultaneously at the same instant of time, then we say Y type of fault is taken place. Then we have another category that is called as H type of fault. Now, what is H type of fault? It is also called as series parallel type. Here, LG is taken place at one place and LLG at another place. Suppose at the sending end, at this sending end, we have LG fault taken place, and at the receiving end, if we have line to line ground fault is taken place at the receiving end, or maybe reverse also. So then we say that it is H type of fault. Now in the further course, we will learn how to deal with this Z type of fault, Y type of fault, and H type of fault. How we can go ahead with the analysis so that we can design a proper protection system for the healthy operation of the power system. Okay, thank you very much in this video. We'll continue in the next video. Thank you very much.